Today we are going to discuss about the life cycles of massive stars. These stars explode in a supernova explosion. Unlike low mass stars and intermediate mass stars, which comparatively quietly shed their outer layers and become white dwarfs. Massive stars become neutron stars or black holes instead. Let's jump right into it. In this video, we are going to talk about stars with more than around 12 solar masses. You might notice there is a small gap between 10 and 12 solar masses. The stars in that range of masses are beyond the scope of this video series, and so I will be covering them in a later video where I will give a small overview of all the things that I could not fully explain. So this is an example star here, and this time I managed to get an actual photo from NASA. The star's name is Zeta Ophiuchi, and it is an O-type star, which has created this sort of shock wave of gas. When the O-type stars run out of coal or hydrogen, they become super giants instead of normal giants because they are much more massive. However, the relative luminosity increase is not that high, as from here it was around let's take an example of the sun. It goes from 1 solar luminosity to around 100 and then to 1,000 solar luminosities. But these stars are already at 1,000 solar luminosities, and then they become 1 lakh solar luminosities. So here it is an increase from around 10 to 100, and here it is an increase from around 100 to 1,000. What happens is that as soon as they run out of core hydrogen, they come and become B and O type supergiants, and then they redden and cool into the M type supergiants. And after that, helium fusion and then carbon fusion, and after a while, the carbon fusion is much faster than helium fusion, and helium fusion is much faster than hydrogen fusion. So it starts going faster and faster, and the rest of the star doesn't have time to respond. And this can happen while it is a blue supergiant or a red supergiant. And this is a picture of a red supergiant, Antares to be specific. It is sort of blurry since it's very far away. Normally a telescope, when it is a star, it's just a speck like this laser pointer, but much smaller. Here it is trying to take a full image of it, and so it's a bit blurry. So carbon fuses to form neon and oxygen, but neon fuses first before oxygen, which is why shell is shown further out than oxygen in this infographic. And then oxygen fuses to form silicon, and silicon fuses to form iron. And iron has a strange property that it is the most stable nucleus. So hydrogen is not very stable, then helium is more stable, and while making the elements more and more stable, the star is getting the energy that is released from them. But now iron is the most stable, so from this, no more energy can be created. But a star will fuse iron anyway. But iron fusion takes away energy. And a star always has to have enough pressure from radiation and heat coming out to match the gravity coming in. But once the iron takes away the energy from the core collapses under its own gravity, and because of the energy released from the core collapsing, the rest of the star takes this energy and so it uses this escape energy to escape the core, and so the star explodes. Now inside the core there are lots of neutrons. The iron nuclei capture the neutrons and then they become much heavier. First it was iron with 29 protons and 30 neutrons, but now it will have much more neutrons. And if an atom has too many protons or too many neutrons, I mean a nucleus, it is unstable and decays radioactively, and so it'll become a larger an element with more protons now, because the neutrons are becoming protons. And this continues very quickly until it goes to very heavy elements like plutonium or americium. But then it stops because this is getting blown apart within a second. And that's how quickly all these elements are created above iron. And uranium and plutonium has 94 protons, and it is 94 the 94th element, while iron is the 26th element. Only 26 elements or so are created in the entire few million years of the life cycle of the star, and then most of the rest and then a large portion of the rest are just created within a second. So then what happens to the core? Some of it was blown away, which is how all these heavy elements come and enter the world. But but it collapses as well, and it becomes either a neutron star or black hole, depending on the mass of the core. And by the core, I specifically mean the iron core. This part also gets blown apart. The iron core, if it has a mass lower than 2.8 solar masses, then it will become a neutron star, otherwise, it will become a black hole. And this is the end of most massive stars, which are very rare. It is why neutron stars and especially black holes are much rarer than white dwarfs. 97% of stars become white dwarfs and only 3% become neutron stars and black holes. Well, that's it for today. See you in the next video, in which we will be discussing white dwarfs. Goodbye.